Hello and welcome everyone. I'm Priya Manand, your host for today's exciting webinar, The Essential Guide to Succeeding in DevOps. On behalf of EducationNest, I'd like to thank you for taking the time to join us for this session, which promises to be full of insights and practical strategies. At EducationNest, we are passionate about providing innovative, impactful learning experiences that drive real world results. We design training programs that not only boost individual skills but also create lasting value for organizations. Today's session will be no different as we explore the world of DevOps. DevOps is more than just a set of tools or processes. It's a cultural and professional movement that's reshaping how organizations develop, deploy, and manage software. At its core, DevOps bridges the gap between development, the dev part, and operations, the ops part, encouraging teams to work collaboratively to deliver software faster, more reliable, and with higher quality. DevOps is one of the most in-demand fields, and we want to ensure that you walk away with knowledge and confidence to succeed. This webinar has something valuable for everybody today, whether you are new to the field or an experienced professional seeking to sharpen your edge. And now, let me introduce our expert trainer for today, Rochak Agarwal, with over 13 years of extensive experience in cloud architecture and DevOps practices. He is a seasoned multi-cloud architect dedicated to delivering innovative solutions that drive business transformations. His expertise spans across designing, implementing, and managing complex cloud environments on platforms such as AWS, Azure, and Google Cloud. He excels at integrating DevOps methodologies to enhance collaboration between development and operations, enabling faster delivery of high quality software. He is passionate about leveraging cutting edge technologies to create resilient and efficient systems that empower organizations to thrive in a competitive landscape. Today, he'll take us through career prospects, industry trends, and essential skills needed for success in DevOps. Before we begin, just a quick reminder, feel free to drop your questions in the comment section throughout the session. We'll have a dedicated Q&A at the end where Rochak will address as many as possible. Rochak, the floor is all yours.
Sure. Thank you. Thank you, Priyam. Thank for such an impactful introduction about me as well as the DevOps. So you rightly said, DevOps is not only the tools and the processes, it's a culture. Okay, so we need to understand if we are learning only some of the tools which we commonly refer to as the DevOps tools. We are not learning the DevOps. So DevOps is more just the tools. Okay, so tools we can say is just one part of the DevOps. So we need to understand like what skills and knowledge are essential to start a career as a DevOps engineer. So we'll start our webinar with this discussion. So there are so many skills needed for a DevOps engineer. And if you see current market, there are other sub-streams also for a DevOps engineer. For example, there is openings for the DevOps engineer. There are openings for the site reliability engineer. Then there is the platform engineering jobs which are available. So we need to learn various technical skills needed to excel in the field of DevOps. So first, we need to understand from the very basics. Okay, tools comes at a very later stage in the area of DevOps. First, we need to understand the basics. And the basic is whenever you are deploying something and you are running something, it is going to run on some servers. Okay, servers, they interact with each other. There is an operating system. So we need to understand operating system fundamental very thoroughly. So if you wanted to become a very good DevOps engineer, you need to understand how operating system works. Okay, at least a basic of the operating system is must have for becoming a good DevOps engineer. Most prominently, we use Linux as our platform for 80 to 90% of the projects. So Linux or any other flavor of Unix also you can learn, but Linux is most widely used. And then some knowledge in the scripting field. It is optional. Okay, so you can learn any one of them, but as a DevOps engineer, your job is to automate the routine task. Okay, now to automate the things, you need some of the programming or the scripting knowledge. So Python comes very handy, and Bash is also very good when you are dealing with the operating system level knowledge. And PowerShell is where when you are dealing with the Windows based system, so you can choose to have. And these languages are very, like, if you know one of them, then you can easily learn other one as well. So apart from this, on the networking side also, because you will not be working with one server, there will be multiple server which are interacted one another. Your application layer is talking to your database layer. Then you have load balancer. So we need to understand all the networking related concept. This is very, very critical. Okay, because without of that, you don't know how your application. Let's say in the end, what we want. Your users are trying to access your application. Now, somehow this connection is broke. You should know where to look out for, because with the complexity which is growing in today's environment, there are so many layers of applications are there, so many layers of tools and softwares are there. So we need to know exactly where to look for. So you need to actually dig deep into the networking aspect and figure out what are the DNS, how the packet is flowing. So these are some of the basic skills. Okay, before even going to any of the tools, these things you should know. Then once you are familiar with these skills, then we can learn the core DevOps tools. Now in DevOps, there are certain life cycles, so that we see in our next question. So for every cycle, there is a tool. Now you can learn the fundamentals about the tool, because it might happen that you are working on Jenkins for the CI/CD purpose. But if you go to other project, they might be using the GitLab CI or the GitHub Actions. And there are other multiple tools are available for each stream. So we have listed out some of the common tools, but you can learn any one of them. There is no good and bad thing about it. It will totally depend on what is the project's requirement. And accordingly, you can select a tool which suits your requirement. So for example, for the version control, we need to learn Git. For continuous integration and continuous delivery, we need to learn Jenkins, GitLab CI, GitHub Actions, Circle CI. You need to know only one of them. Okay, it might be happening that you will be working with different tools. The fundamentals of all the tool in a particular stream will always remain the same. So you can choose to focus on learning just one tool. Containerization, we need to learn Docker. Docker is nowadays de facto standard for learning the new containerization. Then Docker is only good for the development kind of a workload. If we wanted to run containers in a production grade system, so then Kubernetes comes very handy. So without Kubernetes, you cannot scale the containers to a enterprise grade, basically. So Kubernetes is the hottest skill in the market right now. Then comes the infrastructure as a code. Nowadays, if you see, with the DevOps, cloud and DevOps go hand in hand. So we need to create our infrastructure on the cloud, like databases, servers, storage. So for that, we use Terraform or the CloudFormation. Now, CloudFormation is something which is AWS specific. So if you're on 100% AWS, you can go learn CloudFormation. But if you're looking for something that is cloud agnostic, which works with multiple cloud, Terraform is your go-to choice. Then we have configuration and management, and there is these three are the most popular tool in configuration management. You can choose to learn any one of them. And nowadays, Ansible is the most popular configuration management tool by a big margin. So Ansible is little easier also in comparison to Puppet and Chip, but it is more powerful. Okay, so Ansible you can learn, or Puppet or Chip, that is up to your choice. And then in the monitoring and logging, again, in the monitoring and logging, there are n number of the tools. So you need to understand what is the thing that you want to monitor. So for example, for server monitoring, there will be different tools. For application monitoring, there will be different tool. For logging purpose, there will be different tool. So ELK is an open source version. Then Splunk is an enterprise licensed software. Then we have Prometheus and Grafana for the monitoring and logging purpose. So the tool which we listed in the slides are just the reference. Okay, it is not mandatory that if you wanted to go learn DevOps, you need to learn those tools. These are one of the examples of the tool which is available in the market. These are the most common one. So if you know already, let's say for monitoring and logging, you know Datadog, for example, then it is good enough. And when you go to any of the project, and according to the project's requirement, you can scale up. Everyone cannot learn every other tool which is available in the DevOps area, because every 2 or 3 months there is a new tool which is coming into the market. So we need to upgrade ourselves as well. So our focus should not be on the tools. Our focus should be how the tool is working. We need to understand that fundamental. Then, as I said, with the cloud, DevOps, cloud is going in and end, because cloud provide the agility and elasticity to our infrastructure and our platforms. Because if you go on premises, and you want to deploy something, then you need to procure the servers, you need to go for the licensing. There is a very lengthy process. But if you are using the cloud service provider like AWS, Azure, or the GCP, you can just go to the AWS portal and provision a server in a minute. So you can see, and whenever you need the server, you can provision it. And for example, your work is over, you can delete those servers, you can decommission those servers. Everything is on our fingertips. So we need to learn at least one of the cloud. And I will suggest don't go multi-cloud because all these three cloud work almost similar. Okay, so instead of try to learn multiple cloud, go deep in one cloud. So if you're learning AWS, become the expert of AWS. Then Azure and Google Cloud, you will learn automatically. Okay, and in the cloud services also be focused on the core services, which is compute, storage, networking, database, and security also. So this is kind of a mandatory nowadays. Once we know the cloud platforms, we have our soft skills, which comes very handy when we are interacting with our customer. DevOps is all about the collaboration. You are collaborating with your networking team. You will be collaborating with your security team. You will be collaborating with your testing team. So collaboration comes very handy. Then automation mindset. As a DevOps engineer, your job should be, you need to look out what is the thing that we are doing on a daily basis. When I'm saying daily basis, on a repeated basis, you need to look out for the opportunity if the thing which we are doing repetitively can be automated. So that way we can reduce the human efforts. So a DevOps engineer should always have an automation mindset and problem solving skill, troubleshooting issues, because not only you will set up the platform, once your application starts running, there might be the issues that you will be encountering. Then communication, you need to communicate whatever problems you are facing. Let's say you create a solution, now you have to explain that solution to the customers. So communication is also one of the key factors in DevOps. Then we have to learn about the security principle. Whatever you are working on, whatever infrastructure you are creating, it should be secure, right? So nowadays, if you are hearing the term, it is not only the DevOps, it's called the DevSecOps. So with the DevOps, security is embedded. So we need to understand the security principle. We should not be leveraging, we should not be leaving our credentials open in our source code repo. We need to secure our DevOps practices. So security skills are very critical nowadays. Then learning and practice. Learning never stops in DevOps. Okay, so if you think you have become a DevOps expert, then you will become stagnant. Your learning process should always be in continuation, because if we talk about any of the cloud service provider or any new tools coming into the market which you need to implement, so you always have to learn, you always have to implement and practice. And to channelize your learning, you can actually go for these certification, and these are some of the certification we have given. Either you can go for the AWS certified DevOps engineer, Azure certified Azure DevOps engineer expert, Docker certified associate, Kubernetes administration. So there is certificate for every tool which is available. There is a certification for Ansible. There is a certification for Jenkins. So you can choose to do those certification. Those certification are not mandatory, but once you do them, they will give the validation that you know the skill and you have passed a certain skill set to achieve that certification. So that is, of course, completely optional. So these are some of the things that we need to learn to become a successful DevOps engineer. Now, why someone would want to become a DevOps engineer? What are the career opportunities and growth prospect is there in DevOps? Nowadays, if you see, with the environment becoming so complex, cloud is everywhere. There is a very high demand for DevOps engineers because of the increased adoption of cloud, automation, and agile. And as a DevOps engineer, you will command higher than the average salaries for the specialized skill. So let's say if you have become a AWS security engineer or Azure security engineer or a AWS network engineer, then you can command a very good salary in comparison to the other skills. So, and opportunity for the career growth increases as your experience and expertise will increase in the DevOps area. So we'll discuss some of the roles which is available. So you can see as a DevOps engineer, we have a senior DevOps engineer roles is available, where you will be doing the complex automations. You will do the scaling. Then there is the role of the DevOps architect, which will design the enterprise level strategies. Then there is a role for the site reliability engineer, focuses on the reliability and automation. So site reliability engineer will do once your infrastructure is ready. Okay. Your application is serving the traffic, then it should not break. Okay, so this is a responsibility of a site reliability engineer. Then there is a new stream that is coming up, the platform engineer. Creating scalable self-service environment is also one of the responsibilities of a DevOps engineer. Then you can go become a cloud DevOps engineer, security engineer, container specialist, or the automation engineer. So there is multiple streams. See, when we are saying DevOps engineer, okay, if I talk about 5-6 years back, then it was a general terms. People are becoming the DevOps engineer, but now there are so many sub streams is available in the DevOps itself. Okay, you can either go become a security engineer, you can go become a container specialist, managing containers with the Docker or Kubernetes. You can become with automation engineer as well, where your focus is on automating everything. So as a DevOps engineer, whatever the learning path that we have discussed in the previous discussion, okay, so we should be understanding each bit of them, every bit of them, but we should be focusing on becoming an expert into one of them. You can be a, let's say, very good expert CI/CD engineer, or you can become a very good network engineer or a security engineer. So then there is some of the emerging trends and technologies which is get traction and availabilities in the market. One is the GitOps. Okay, so GitOps, we use GitOps using Git for the deployment pipeline. Now, this is a very new approach, and here in the GitOps, we use this where we talk Git as a single source of truth. So whatever is happening in your GitHub repository, and any changes which is happening in your GitHub repository will get reflected to your deployments. So that is another method which is getting popularity. Then, of course, AI is anyways getting popularities, but AI and machine learning in the DevOps. Okay, how we can leverage AI and machine learning in DevOps is getting like, if you know some of the AI technologies, implement where you can implement the AI. So, for example, I have recently encountered a platform where you just need to tell as a prompt, like I'm sure everyone is having an encounter with the ChatGPT, where we ask a question to ChatGPT and ChatGPT gives us the answer. Okay. Similarly, I have seen the platform which is coming into the market, in which you will just tell them, I need to deploy a 3-tier architecture in AWS. That's it. And it will do everything in the background for you, and it will deploy the complete infrastructure and architecture for you in the backend. You don't have to do anything. So AI and machine learning also becoming integrated part of AWS or the DevOps. Then serverless computing, reducing infrastructure management, everything being abstracted from us. And in the last, we have something called the edge computing. Edge computing is like managing. You are taking the server's computation to that level where the traditional computing power is not being present. So, for example, there is a ship which is going into the sea, deep sea, where there is no network available. And there also you are sending the computational power, that is called the edge computing. And then there is business and consulting roles are available in DevOps. So DevOps, you can become a DevOps consultant, which advise the companies on best practices and optimizations. product manager for the DevOps tools, overseeing the tool development. You can give the feedback. So because see in the tool, if you see these tools, whatever these tools are available, these are the product in the back end, right? So whenever someone developed, they developed Ansible, they developed your what you can say is Docker or Kubernetes. So we can become a product manager to give feedback. Okay, this thing was needed, so they can be incorporated in those products as well. So there's a business and consulting roles is also available. And so there is a industry trends are available. Remote working is with the DevOps for the DevOps job. There is the maximum number of the remote work is available in the DevOps. Okay, because anyways you are interacting with the cloud. So cloud is anyway you can access it from anywhere, right? There is a cross industry demand. Tech, finance, healthcare, manufacturing is there. Open source contribution you can do, which enhance the visibility and influence your influence. And in the end, there is a certification and continuous learning we can do. So there is multiple valuable certifications is available. We can do continuous learning, staying updated with the emerging tools, and we can adapt to the evolving DevOps landscape. Now, what are the key phases of the DevOps life cycle? So there is some important key phases in the DevOps life cycle. First, it goes through the development phase, then testing, integration, deployment, and monitoring. First, you develop some product. Okay, then you test that product, and you are not only the developer of that product. There will be multiple people who is taking part with you in the development. So you will integrate your changes with their changes. That is called the integration. Then you deploy the whole product and you keep monitoring it. And this is not a one-time process. Okay, this is the continuous process. So it is not like you will deploy everything at one go. You will develop everything at one go. You, let's say, release one feature of it. You test one feature, you integrate one feature, you deploy it, and you monitoring it. Then after some time, you will do again something, and so and so. So development is the first stage of the DevOps lifecycle, in which development of the application take place constantly. The entire development process is broken down into the small steps or the development cycle. As a result of this, the speed of the software development and the delivery is increased. So then we do automation testing as well. So testing tools like Selenium is used to speed up the overall testing process. So we integrate this testing tools like Selenium, JUnit, or any other testing tools in our CI/CD pipelines. Then we integrated new functionalities are integrated with the existing code, and testing of the new code will takes place. Once this is testing is integrated, testing is done, integration is done, we deploy it. Continuous deployment is a part of the DevOps lifecycle, and it is a very, very important part. When it is performed in the right way, it can affect the overall functioning of a high traffic website. Okay, so like if you see nowadays everyone is going and accessing these e-commerce website, right? So these e-commerce website, these e-commerce website, you can see after you go sometime there was a new product which is which you get it, new offer, this is coming. So because how you are getting it, because someone is developing those features and deploying it so that we can use it. Then we have this monitoring in place. Appropriate system behavior is managed by monitoring. Through proper monitoring, the bugs are found and fixed is a hassle-free way. And these are the building blocks for any DevOps application. Now, we keep discussing that cloud are going hand in hand with the DevOps cycles. Okay, so how do we manage infrastructure as a code using tools like Terraform or Ansible? So when you use any of the cloud service provider, Azure, AWS, GCP, you are creating infrastructure over there. So infrastructure can be your servers, your databases. Now you need to, when we create the infrastructure, we need to make sure no one is actually tampering with this infrastructure, because what can happen is you will not be the only one who is single-handedly working on this infrastructure. There are multiple people. Right. So it might happen that you go and create one server, someone go deletes it. Now, how will I find out who has deleted it, or someone goes change it? So you need a unified way to manage your infrastructure, and that is called the infrastructure as a code, where you define your infrastructure in some codified format. Okay, and you maintain that code with you. So whenever you see the current code, your code is different from your current infrastructure, then you will sync your code basically, right? So the benefit of the infrastructure as a code is there's an automated deployment, consistent environment, because whatever is written, this will be reflected in the environments. Then it is a repeatable process, reusable components, and documented architecture. So all these are the benefit of the your infrastructure as a code. And then how we are going to automate infrastructure deployment. So we need to provision the resources, we need to plan the updates. So what we do is we write our infrastructure in some specific language which the infrastructure as a code tool understand. So we'll see one of the most common tool is Terraform. So we write reusable templates in the Terraform language, and we store them in our source code control. Okay, once we store them in the source control, then what happens is we can use them whenever we want. So Terraform is a go-to tool for using the infrastructure as a code, where it's a cloud agnostic tool, the first thing. Okay, so a provisioning declarative tool that based on the infrastructure as a code paradigm. Now, understand this declarative thing. There is two way of managing the things. Okay, one is the imperative way, another is a declarative way. Now, what happens in the imperative way is, let's say I need to go from place A to place B. Okay, now in the imperative way, if I draw an analogy, imperative way is like I will drive my own car. So then I need to know how to reach from point A to point B. Okay, so I need to know when to turn left, when to turn right, how much go straight. So everything I should know, right? This is called the imperative way. Second is the declarative way. In the declarative way, what you will do is, let's say I'll book an Uber and I'll tell the person that I need to go to point B. Okay, now I don't need to know how the person is taking me to the point B, but in the end result is I need to go to point B. So that is a declarative way of doing the things. Okay, so most of the common modern tool nowadays, if you see Ansible, Terraform, Kubernetes, these all are the declarative tools. Okay, now what happens in the declarative tool is, if you need to provision one server, okay, I will tell Terraform I need one server. Okay, I don't care how Terraform is provisioning it. So we just need to tell Terraform what infrastructure you need, and Terraform in turn will provide that infrastructure for you. And for that, Terraform uses the syntax which is written in the HCL. HCL is a HashiCorp configuration language. Now, HashiCorp is the organization or a company which owns Terraform, which developed Terraform. Now, Terraform itself is written in a Golang language. It helps to evolve our infrastructure safely and predictably, and applies graph theory to infrastructure as a code paradigm. And now it's a multi-purpose composition tool. There's a multiple tiers we can use, and a plugin based architecture model is there. Now it's an open source backed by the HashiCorp company and their guiding principles. Okay, so if we wanted to build any tool on top of the Terraform, we can do so as well. Now, next topic is what is GitOps and how does it differs from the traditional CI/CD practices. Now, GitOps, as it say, it is repeatable, predictable, auditable, and accessible. Now, repeatable means apply changes the same way in every environment, even your entire stack all at once. So whatever you are doing to one environment, you can repeat it to, let's say I have 4 environments, dev, test, prod, pre-production. So whatever you are doing in one environment, it will be applied to all of the environments, even your entire stack all at once. Okay, then it is predictable. Predictable means comprehensive understanding of the deployment impact, declarative with a known end state. Okay, so declarative, as I said, you just need to tell what it need to do. It will do the things automatically. Then it is auditable. So whatever changes has been done, they are traceable. You will get to know who has done it, when they have done it, and what they have done it. So understand the exact state during any prior time period, we can do so. And accessible changes only require a pull request. Now, we can practice DevOps in deploying the infrastructure as well as applications. So pull requests drive all application and the infrastructure changes. Cluster state always matches the Git state. Now, what does it means is, so for example, I have some code in Git. Git is our source code version control system. So now whatever is there in the Git, your cluster, your application should always match that state. Okay. If there is any variation, Git will, what it will do, your GitOps tool, it will sync your state, your current state with your Git state. So tooling should understand and monitor the configuration drift. So that is called the configuration drift. Okay. So let's say if I configure it for the 10 instances, okay, and currently they are running the 10 instances, but after some time, someone reduce the number of the instances, let's say 5, but your infrastructure is running with the 10 instances. So that is called the configuration drift, when you have different thing in your Git and your current environment has a different thing. So that is called the configuration drift. Deployment and rollback should be painless. So you should not, if you go on to any previous state or anything at all, they should be painless. And developer, now with the GitOps, developer focus should be shifted fully on the feature development. They don't need to worry about how my application will deploy, how I will roll back when things go bad. They don't have to worry about anything. Okay. Now, since we are talking about the deployments, there is a very big pain point which says what are the when you deploy a newer version of the application. Okay, so when we deploy a newer version, previously with the traditional deployment methodologies, what was happening was, when you deploy something, you need to either take a downtime, and during that downtime, your application was not available to the users. But now with the advent of these high performing application, downtime was not an option. Okay, so every application was demanding the zero downtime. Now zero downtime means your application should be available at every point of time. Okay, so if your application should be available at every point of time, then how I am going to deploy a newer version of my application? So that where these Blue-Green and the Canary release deployment comes into the picture. So there is a different type of methods available. One is a canary deployment, one is a rolling deployment. Then we have a feature toggle, or we call it as a feature flags. And in the last, we have something called as a Blue-Green deployment. Now, most common one is a canary deployment or the Blue-Green deployment. Now, what happens in a canary or a Blue-Green? So in the canary deployment, a new version of application is released to a subset of a user or servers before making it available to every user base. Okay. Now this subset is often referred as the canary group. The performance and stability of the canary group are monitored, and the rollout is gradually increased if the application is functioning as expected. The impact due to any issue is limited only to the respective canary group. So for example, my application is running with 10,000 users and I want to deploy a newer version of that application. I will, let's say, deploy it with 100 users only. So if any impact is going to have, this is going to impact only with those 100 users. If the performance is good for 100 user, I'll slowly eventually will move it to 500 user, then to the 1,000 user, then to 5,000 user, and then to the full 10,000 users. Second is a rolling deployment. In a rolling deployment, the software in the production is gradually updated, one server or the instance at a time, This process is continued until all servers or the instances has been updated. Continuous server availability is ensured by the rolling deployment, but a mix of old and new version may run simultaneously during the deployment. So what does it mean is, let's say if my application is running on 5 servers, and if I wanted to deploy a newer version of my application, so I will deploy first on first server. Once this is done, I'll take down the second server and refresh it, then the third server, then the fourth server, and then the fifth server. So at any point of time, my application will be available with the rest 4 of the server. But it may happen, let's say my first server is updated, it is running with the newer version, but all my remaining 3 or 4 servers, they will be running with the previous version. So that is one issue with the rolling deployment. Then we have the feature toggle, which commonly referred to as the feature flags. So feature toggle referred to the practice of incorporating the code for the new feature directly into the production code base. However, visibility and the activation of these features are managed through the configuration setting. Okay, the approach grants the ability to activate or deactivate a specific feature without the need of redeploy the entire application. Feature flags as part of this technique facilitate gradual implementation and enable the A/B testing, or we call it as a alpha beta testing, by controlling which user or segment experiencing the new features. Okay. Then in the last, we have the blue-green deployment, and this is again very common one. In the blue-green deployment, 2 separate environments are maintained. One we call it as a blue environment. Second we call it as a green environment. Initially, all the traffic is, let's say, redirected to the blue environment, and when you update a new version, an update is released, it is deployed to the green environment and thoroughly tested. Once confident that the green environment is bug-free and stable, traffic is then switched from blue to green in one go. This approach easily follows for the easy rollback, and by switching the traffic back to the blue environment if there is any issue that arises. So this is a diagrammatical representation of the blue-green deployment. So you can see these are the end user. End user will send the traffic. Let's say there will be one blue environment, then second is a green. So your traffic is coming to the V1, which is your blue environment, and you deployed another version to which is a green environment. So running environment, current production is blue. Now what you will do is your production traffic is coming to blue environment, but you will send your test traffic to your green environment to test your application if it is stable and bug-free. Okay. Once your testing has been done thoroughly, you will cut your production traffic from blue environment to the green environment. So post deployment and traffic switchover, green environments become your production environment, and the switching will happen. So that is just a simplified reference architecture for a blue-green deployment. Okay. Now, once everything is done, you deploy everything, there comes the observability. Okay. Now, observability is a very key features in DevOps, and there are various tools available in the market right now which will help you achieve this observability. Okay, so first we need to understand what is observability. So when we talk about observability, now in your application, there is like multiple sources, the data is coming and they will be related to each other. Your database will be there, your networking stack will be there. So you need to, you will not be able to figure that out, that if any error is coming. Okay, so if any error is coming, from where this error is coming. So you will probably need a single point, a single pane of dashboard or a glass where you can see everything what is happening in your environment. Okay, so your environment will have an operating system, your environment will have a database, your environment will have a network packets going from point A to point B. So you need to, like, you cannot go at each place within these complex environment and troubleshoot the issue. So you need something where you can get a bird eye view, a holistic view of the complete infrastructure which are there in your environment. And with the rise of microservices in the cloud, okay, now it is extremely hard to monitor and troubleshoot the microservices, because previously what was happening is that we run on the monolithic architecture. Now, in the monolithic architecture, there was only one application, which is generating log at the single place. Okay. So host-based monolithic is this, in which your all the functionality will get integrated into this one monolithic application. Now, what we did it, we moved to the microservices based architecture, which says we break down the functionality in multiple microservices, which will be deployed into multiple servers and so on. And then nowadays there is an abstracted host highly distributed. So you when we use any of the cloud service provider, okay, so we don't even know where my microservices is running, but they are interacting with each other. So there is a Docker container, there is Kafka, Postgres, Docker Compose, Twilio, AWS Lambda. Now they are not running on a single server. Okay. Forget about the server, forget about the single server. We don't even know where they are running, because that's the job of a cloud service provider, that the infrastructure is abstracted from us. Okay. So we don't even know from where are the services are even running. So it becomes very challenging how to monitor it. Okay. So that is where we have our traditional monitoring solution will not come to the rescues. Okay, so because logs and matrices are not enough, bytecode becomes a bottleneck, and manual monitoring skill agility. Now, what do you mean by the logs and metrics? So logs is what your application is doing at any point of time will get stored in the logs. Okay, and the metrics is what is the snapshot of your system. So, for example, I'll say what is the CPU utilization of your system at this moment. So that is the metric. But nowadays, they are not enough. Okay, we need something called as a traces. Traces are needed on top of metrics and log, and distributed tracing is crucial in order to find the root cause efficiently. Now, traces is your one microservice will be communicating with, let's say, 50 other microservices. So we need to make sure that where exactly the problem is happening. So we need the traces, we need the user journeys. Where the latency is coming, where it is working fine. So that becomes very important. Then we have a bytecode becomes a bottleneck. Bytecode provide limited value in the distributed application, and this comes with a significant overhead in the microservices environment. And if we are manually monitoring, then getting distributed traces require manual instrumentation. Metrics, logs, and traces are correlated manually. So if we are manually doing it, then it will become like a bottleneck for us. We cannot do the automated solution. Let's say if something is happening and based on that I want to do something, but if we manually monitor something, we cannot do the automations, right? So for example, if my server is down, the first thing it should do is to send me an SMS. Okay. So if we had, let's say, traditional monitoring implementation I'm doing, for example, by some script, I can do that. I can write in a script which will do it for me, which can tell me if my server is down or not. But I cannot write an automation on top of it. So we need some more solution, which is there. So why distributed tracing is critical today? Because this is the only way to understand the cloud native workload. Due to the high complexity and the need for the manual intervention, distributed tracing remains an approach viable only for the very tech-savvy companies. And a trace is basically tells the story of a transaction or a workflow as it is propagates through a distributed system. So for example, your request, this will go to first to your API gateway, then it will go to your Lambda, then it will go to your Kubernetes cluster, then it will go to your database. So your request, you can see, is going through multiple hops. Okay. And there will be multiple services. So trace is from its origin point, where all the request is going. Everything will be monitored in that trace. So trace tells the complete story of a transaction or a workflow as it propagates through a distributed system. And that is why distributed tracing is very, very critical today in terms of distributed applications. So yeah, with that, we have covered some of the necessary topics that is there into the world of DevOps. So now I will leave the floor open for the questions. So yeah, if you have any questions, I will be happy to take those.
Thank you. Thank you so much, Roger. That was incredibly insightful. Can you please just go on to the next PPT where we are sharing our social media handles? So this
Sure.
is
Yeah.
the list of all our social media handles. I would encourage our viewers to please follow us on whichever platform you're comfortable, because for regular updates on our upcoming webinars, on our courses. So it's a great way to be in touch with us and to know what when are we coming up with what all webinars we are coming up. So thank you, Rojak. You can please stop your screen share.
Sure.
So it's just us now. As you said, let's move on to our Q&A round. We have a few questions already on our screens. I urge everybody who, if you still haven't posted your question, please do so right now. You still have time. Okay, Rochak, first question for you today is, which is the better career option, DevOps or data science?
Okay, see, we cannot actually compare orange to the apples. Okay, they both have its own benefit. Both of the fields are very necessary today.
Yeah.
And now, as we are seeing, data is a new oil. So every company needs some data analytics, some data science, which is needed. Okay, but sometimes what happens is you to implement the data science, you need the DevOps pipelines. So they are not the enemy of each other; they are complement to each other. So both fields are necessary. Both fields are rising. Both fields have a huge demand of professional who has the right skills. And from the salary wise, also they are offering very good salary in comparison to other traditional skills.
Okay, so you want to say that there are benefits for both, and
See,
you
the thing
can't
is,
compare
there's benefit for
the two.
both, and the thing comes about your interest. Some people they have a very good interest in the data analytics, so then you can choose to go that way. And someone who is good with the automation and other stuff, they can go by the DevOps area.
Okay, so I think you very nicely answered that it depends on your interest. Wherever both are, I think, in
Yeah,
demand right now. So it's
in the
just
demand.
up to you, whichever you
Correct.
have your interest in, and you can go ahead about it. Okay, next, I think you might have answered, but I'm still taking this question. Is a formal degree required, or can I enter DevOps through a self-study and certification?
Okay, see, DevOps is there is no formal degree assessed for the DevOps. Nowadays, many online portals they have started some of the courses with the various universities, but as of now there is no formal degree which is required. But what you can do is you can do self study and then do some of the certifications which will validate your knowledge, and these certifications are accredited by the these organization which is dealing in the DevOps. Like for example, you can go for AWS certified DevOps engineer or the Azure certified DevOps engineer expert or certified Kubernetes administrator. So this will validate that you have the knowledge in that correct field, and with the knowledge and the validation, you can apply for the job. So there is no formal degree needed in DevOps.
Okay, all right. Thank you so much for answering this question. Moving on to our next question. How does DevOps reduce the deployment frequency?
Okay. See, what happens in the DevOps is if you let's say you do not have the DevOps pipeline. Okay. So what will happen? There is multiple developer team in the production. When you go with the corporates, it's not a single developer who will be working on a product. There will be multiple developers. Now what will happen is I develop something, I checked in the code into the source code management, and then I'll go manually deploy everything. Okay. Now once I'm done with the deployment, another person comes and they say, no, I wanted to deploy my changes also. After that, another person comes. So without the DevOps, it can become very chaotic. And this can arise when you have a 4 or 5 developers. Let's imagine you have a 20 developers. How you are going to keep track who is developing what and how their changes are going. Let's say what will happen is I do something. On top of it, you go and deploy something. Your changes broke my changes. Okay, so then it can create a complete chaotic environment. That is one thing. Second thing is when you create DevOps pipeline, as soon as I am entered. So when we have the DevOps pipeline, first thing is you will have something called as a source code management. So every developer's code will go to the source code management. So this means there is no conflict if it is merged into the source code. And once it is merged into the source code, our automatic build will already be triggered. So it means there is no breaking of the code of each other. And as soon as, and this will be a complete automated process, and as soon as you checked in something into the source code management, a complete DevOps pipeline will trigger. So that is how it is reducing the deployment frequency.
Okay, that was really informative. Thank you so much, Rochak. The next question is, how can multi-cloud storage strategies enhance DevOps processes, and what considerations should teams keep in mind?
Okay. See, multi-cloud strategies, even though cloud strategies, I would say, will come into the handy because cloud provides the agility and elasticity to our DevOps environment. I mentioned this point as well. When, let's say I have an idea, I start coding that idea. Now I have the product ready. I need to release it to the customer. Okay. If I'm a traditional IT company, what I need is I need some servers, I need some licenses, and that will go through the red tapeism. Like there will be a purchase department. It can take months basically. Okay. But if I'm using the cloud service provider, I can go to AWS or Azure and I can create a server in 10 minutes. And my idea will be live. Once I have the product ready, I can make it live to the customer in, let's say, 1 hour. So DevOps with the cloud will actually bring the real game changer with the increased elasticity and agility basically. Okay, and since there is multiple clouds are available, so we need to actually look out which cloud is good for you, considering like for example, nowadays it is considered that if you have some AI and ML solution you are developing, then GCP provides you very good AI and ML capabilities. And if you're already using Office 365 and you want to integrate your Office 365, you wanted to integrate your Office 365 suite with your cloud service provider, then Azure comes very handy because Azure is also a Microsoft product with Office 365. And for all general users, AWS provide very good suite of services. So then keeping in mind what is your use case, you need to select the cloud service provider accordingly.
Okay. Yeah, got it. Thank you. I hope the person who asked this question also, it's clear as it is clear to me as well. The next question is, what trends do you foresee in the DevOps landscape over the next few years?
So we have discussed this, PM, already in our slides. GitOps is one of them. Okay, GitOps is getting very much popularities. IAC, I would not say because it is already established now in the market. Without IAC, there's nothing happening. So IAC is a established practice now. AI and ML integration with the DevOps is getting huge demand nowadays. So whenever there is somewhere if we can implement AI, then I gave one example where we just tell the prompt, the AI engine, that I need this type of infrastructure, and they'll get everything for me. So this is one trend, that is coming into the market like crazy.
I agree. AI is like the next big thing. You name it, and AI is being used over there. It is all around us, wherever we go. And that is why people even predict that there'll be less human interaction, more of AI interaction with people. Yeah. Okay. Moving on. What areas of DevOps process benefit most from automation, and how can teams get started?
Okay. See, automation is a very key aspect of DevOps. So as you say, when someone say you know Java, so Java has a fixed curriculum, like struts or servlet and whatever the curriculum is. But when you know DevOps, two person who knows DevOps can be completely different. Okay, your understanding of DevOps can be very different from my understanding of DevOps. Okay, so DevOps is not a fixed set of technology or tools. DevOps is just the guiding principles. Okay, now one of the key guiding principle of a DevOps is automation mindset. Whenever you see the opportunity of automation, so the key principle about the automation is whenever you are doing some stuff on a regular basis, It might be on a weekly basis, it might be on a daily basis, and depend on how much effort you are putting up in that task. So for example, if I'm doing some task on a monthly basis, but I'm putting only 10 months, 10 minutes in it. Okay. And to automate that, I need to put up, let's say 20, 50 hours. Then I will probably not automate it. But if I'm doing that task on a daily basis, then I will automate it. Okay. So you need to foresee what effort you will save after automating it, and how much time you are investing in automating that task itself.
Okay. All right. Got
Okay.
it. Thanks, Rochak. Let's move on to the last question of today's session.
Sure.
How can teams ensure effective communication and collaboration between development and operations?
See, DevOps is all about the collaboration. Its name itself suggests Dev and Ops. So, without the collaboration, there is no DevOps. So, we need to effectively communicate and collaborate with our development team, not only with the development team, with our testing team, with our systems team as well. So, DevOps is like a bridge between your dev and your operations. So you should have a knowledge about what is going in the development from your application perspective, and you should know about from the system perspective. So you bridge these two worlds. DevOps team bridge these two worlds basically.
Okay. All right. Thank you so much, Roja. Those were some fantastic answers. And thank you to everyone who participated so actively. And I hope all your questions were answered and you found this session really helpful. There's a world of opportunities in DevOps and it's only growing. And the best part is that even if you have no prior experience, with the right
Correct.
strategies and mindset, you can break into this field and thrive. Before we wrap up, I want to remind you that at Education Nest, we offer customized training programs across all domains to help you continue your learning journey. We hope today's webinar has sparked some new ideas and provided clarity on what it takes to succeed in DevOps. If you found this session useful, please feel free to share it with your network and spread the word. On behalf of the entire Education Nest team, thank you once again for joining us. And of course, a special thank you to Rochak for leading this insightful
Sure.
session.
Thank
So stay curious, stay inspired, and we hope to see you in our upcoming webinars. Take care. Have a fantastic evening. Thank you,
Goodbye,
everyone.
Priyam. Thank you, everyone.
Thank you.